Hello everyone, welcome to yet another video lecture. In this lesson, we look at how to install Kubernetes on Ubuntu 22.04. Now, Kubernetes is an open source container orchestration platform that is used for automating software deployment, scaling, and management. It was originally designed by Google, and the project is currently being maintained by the Cloud Native Computing Foundation. Now, Kubernetes is an excellent tool for managing containers across diverse nodes. It allows you to automatically scale your applications when need be, and also provides a self-healing feature that automatically restarts failing containers and replaces the unhealthy ones with new ones. Now, to get started with this lecture, you need to have two nodes. So this is our current setup. So we have the Kubernetes master node, and we also have the Kubernetes worker node. Now, for both nodes, you need to ensure that you have at least 2 CPUs, 2 GB of RAM, at least 2 GB of disk space, and a reliable internet connection. Now, in our setup, we have already deployed our nodes at Cherry Servers. Now, Cherry Servers is a leading European cloud service provider that is committed to offering private and secure cloud infrastructure to small and medium businesses at a cost-effective fee. All right, so now we already have our setup in place. Now, let's get started with installing Kubernetes. All right. Now, with all the prerequisites in place, let's dive in and install Kubernetes. Now, the first step is to disable the swap area. Now, in Kubernetes, all deployments should be pinned within the CPU and memory limits. So the reason we are disabling swap is to prevent a situation where the pods will use the swap area, leading to degraded performance. So now we're going to disable swap on both the master and the worker node. So to do so, on the command line, run the command sudo swap off -a. Now this temporarily disables the swap area. Now, to permanently disable swap and to persist the change even across a reboot, run the following sed command. So sudo sed -i. So we are going to disable the swap on the FS tab. All right. So here we have swap. So we are going to comment out the swap entry in the FS tab file like that. So here we have etc FS tab. So hit enter. All right. Now, to ensure that the swap area is turned off, run the command sudo swap on --show, hit enter. So here we see we have no output, and this shows that swap area has been turned off. All right, so now we're going to repeat the same commands, all right, on the worker node. So we will switch to the worker node and run the same commands. Okay. So I'm going to copy this also, and I'm going to run it. And just to make sure that swap is turned off, I'll run this command. Great. So now we have successfully turned off the swap area. Now, in the second step, we are going to configure the host names on both nodes. When working with Kubernetes, it's always recommended to assign host names for nodes so that Kubernetes can use these host names to identify the nodes within a cluster. So in this section, I'm going to show you how to set up host names for both the master and the worker node. So here I am on the master node, and to assign the host name, I'm going to run the command sudo hostnamectl set-hostname. Then I'll provide the preferred hostname for the node. So here I'm going to provide it with k8-master. So feel free to assign your preferred master node name. So in this case, I'm using k8-master. Then I'm going to hit enter. Then I'll provide my password. Okay, now to implement the change immediately, I'm going to run the command exec bash. And as you can see, the hostname has now changed from sensible-tapir to k8-master. And just to confirm the new hostname, on the command line, run the command hostname like that. And as you can see, we have the k8-master. So in the same vein, head over to the worker node and repeat the same steps. So here, I'm going to have sudo hostname ctl set-hostname. Then here I'm going to provide the name k8-worker like that. Then I'm going to hit enter. I'll provide my password. Okay, then I'm going to run the command exec bash. All right, and just to confirm that everything went well, I'm going to run the hostname command. All right, so here we have the master with k8-master as the host name, and here we have the worker node with k8-worker as the host name. All right, so now the next step is to update the etc host file to enable hostname resolution. Once you've set up the host names, you need to go further and map the host names to their respective IP addresses as well for hostname resolution. Now to do so, you're going to update the host file in each of the nodes. So now on the master node, access the host file. So run sudo nano. We are going to use the nano text editor and provide the path to the host file. So that's the path of the hosts file. So hit enter. So at the very bottom of the file, you need to add the entries for both the master and the worker node. Okay. So now here I'm going to provide the IP address of the master node, which is 10.170.16.31. So this is followed by the hostname of the master. So this is k8-master. Also, I'm going to provide the details for the worker node. So the IP of the worker node is 10.170.16.50. Okay, so here we have the host name for the worker node, which is k8-worker like that. All right, so I'm going to save the changes. So to do so, I'm going to press Ctrl O, then I'll hit enter. Then to exit the editor, I'm going to press Ctrl X. All right, so I'm going to just verify the host file. Okay, so as you can see here, we have the entry for the master as well as the entry for the worker node. So similarly, head over to the worker node. All right, so once again, access the host file like that. All right, so at the very end, add the entries for both the master and the worker node. So here we have 170. We have 10.170.16.31, and the host name for the master node is k8-master. For the worker node, we have 10.170.16.50, and the host name is k8-worker, like that. Okay, so we'll save the changes and I'll exit. Alright, so we have updated both nodes. We have updated the host file on both nodes. Okay, so now let me try and ping the host name for both the master and the worker node from the master node. So here I'm going to have ping-c. So I'm going to send for requests. Then I'll ping the host name for the master, which is k8's master. Alright, so as you can see, we get a positive response. So now let's ping the worker node host name. And you can see we get a positive result from the worker as well. So let's head back to the worker node and repeat the same steps. So I'm going to ping the master, k8's master. All right. Then I'm going to ping the host name for the worker node. Good. So we can see that the host name resolution is working as expected. All right. So we are moving on quite well. Now the next step, we are going to configure IPv4 bridge on all the nodes. So see you in the next step. So in this step, we are going to set up IPv4 bridge on both nodes, and this involves loading the kernel modules. So here I have a configuration. So I'm going to copy this. So this command creates a configuration file for Kubernetes and adds a few entries. So I'm going to copy this and I'm going to paste it on the terminal. All right, so this creates a new configuration file which is called k8.conf and adds these two entries, which is overlay and the br net filter. So here I'm going to press enter. Okay, so those two entries have been added. Okay, so I'm going to load both modules by running the modprobe command. So here we're going to have sudo modprobe overlay and sudo modprobe br net filter, like that. Hit enter. All right, so next we are going to persist. We are going to create another file and add new entries. So here once again we're going to create a new file. So I'm going to copy this and I'm going to paste it on my terminal. So here once again we are creating another Kubernetes configuration file where we have added these three entries on the terminal, as you can see. Okay, so I'm going to hit enter, and as you can see the entries have been added. Okay, now we are going to persist the changes, and to do so, run the command sudo cctl -- system, press enter. All right, so this has applied all the changes that we require. Okay, so now also do the same to the worker node. So I'm going to repeat the same steps that we have just carried out. So once again, I'm going to copy this block of code here I'm gonna paste it, hit enter. Okay, then I'm going to load the modules, sudo mod probe, overlay, and sudo mod probe br underscore net filter. Okay, next I'm going to copy this block of code as well. I'm going to hit enter and apply the changes to apply across a reboot. Alright, so we have created the IPv4 bridge on both the master and the worker node. Alright, so now the next step is to install Kubernetes packages. So see you in the next step. So now let's go ahead and install Kubernetes. Now we're going to install 3 main Kubernetes packages. So we're going to install kubelet. Now this is a node agent that runs on every node and is responsible for ensuring that containers are running in a pod as specified by the pod specifications. The other package is the kubeadm. Now this is used to bootstrap a Kubernetes cluster, including setting up the master node and helping the worker nodes join the cluster. And lastly, we have Kubectl or kubectl. Now this is a command line tool for Kubernetes that enables you to run commands to perform various actions such as deploying applications, inspecting resources, managing the cluster, and so on. So now, before installing the packages, you must update the local package index. And to do so, run the command sudo apt update. Okay, so I'm going to run this on both nodes. So on the worker node, similarly, update the package lists. Alright, so this is done. Okay, now the other step is to install the requisite packages. So I'm going to run sudo apt install. So we have curl CA certificates, then apt transport HTTPS. Okay, then I'm going to press enter, then press Y and hit enter. Okay, now we have installed the requisite packages. So similarly, I'm going to do this on the worker node as well. Okay, so I'm going to copy this and do the same on the worker node. Y for yes, and then I'll press enter. So we are done. Okay, so back to the master node. Now the next step is to fetch the public GPG key from Google. Okay, now to do so, run the following command. So I'm going to copy this command here. Okay, so now this command is going to fetch the Kubernetes GPG key from Google. So I'm going to paste it. Okay, then I'll hit enter. Alright, now the next step is to add the GPG key and create the Kubernetes repository and add it to the system. So I'm going to copy this command and I'm going to paste it on my terminal. So this command adds the GPG key we've just fetched and creates a Kubernetes repository on our node. So I'm going to press enter. Okay. Then I'm going to refresh the local package index once again. So I'm going to run sudo apt update. Okay. So as you can see, we have entries for Kubernetes. Okay, as you can see here. All right, now let's install the Kubernetes packages. All right, so now I'm going to clear the terminal and I'm going to run the command sudo apt install. So kubelet, and you're going to specify the version. So we are installing 1.26.5-00. Then kubeadm, and we install the same version as well, 1.26.5-00, and kubectl version 1.26.5-00. Okay, so here I made a slight mistake. So this is 1.26. Okay, so we're installing kubelet, kubeadm, and kubectl, and we are ensuring that they are all of the same version. So I'm going to hit enter. So when prompted, type Y and hit enter. Okay, so this will install the Kubernetes main packages, and this might take a bit of time. So in the meantime, okay, we are done. Great. So now we're going to repeat the same steps on the worker node. So once again, you need to install, we're going to fetch the GPG key here. Okay, so I'm going to copy this. Okay. Then I'm going to add the GPG and create the Kubernetes repository on the system. Okay. Then I'm going to update the apt cache, sudo apt update. All right, and finally I'm going to install the Kubernetes packages. Okay. So in this step, we have installed Kubernetes packages on both the master and the worker nodes. Okay. So now the next step, we're going to install Docker, which will underpin the containers. So see you in the next step. In Kubernetes, we need a container engine or a container runtime in order to run the containers. Now here we are going to use Docker as our preferred container runtime. Now, as we've just mentioned, a container runtime is a component that allows containers to run on a host system. So here we are going to install Docker on both nodes. Okay. So to do so, run the command sudo apt install docker.io, hit enter, type yes and hit enter to install Docker. Okay, So we need to do this on the worker node as well. Okay, so I'm going to run the command sudo apt install docker.io, type yes and hit enter. Okay, now we're going to configure containerd on all the nodes to ensure its compatibility with Kubernetes. So on both nodes, I'm going to create a directory for the configuration file. So here I'm going to make a directory sudo mkdir, so etc containerd. Okay, then I'll press enter. Then I'm going to create a default configuration file for containerd. Okay, so I'm going to run the command sudo sh-c, so containerd config default. So I'm going to save this to etc containerd. Then I'm going to create a configuration file called config.toml. Then I'll close with a double quotation mark. Okay. So now I'm going to press enter to create the file. All right. Now, after these commands, we need to modify the configuration file and locate the entry that sets systemd cgroup to false and changes its value to true. Okay, and this is important because Kubernetes requires all its components, and the container runtime uses systemd for cgroups. Okay, so now we're going to run this command here. So I'm going to copy this command and paste it on the terminal. So this sets the value assigned to systemd group from false to true. Okay, now I'm going to, so now I am going to hit enter. Okay, then I'm going to restart the containerd service. So to do so, I'll run the command sudo systemctl restart containerd.service to effect the changes made to the configuration file. I'll press enter, and I'm also going to restart the kubelet service. So here I'm going to change this to kubelet.service. I'll hit enter. All right. So now I'm going to also enable kubelet service to start on system reboot. So here I'm going to change this to enable. Then I'll hit enter. Okay. Right. So now we need to repeat the same steps on the worker node. So I'm going to copy these commands one by one. And execute them on the worker node. So we create the directory for containerd. Then we create the configuration file. Next, we are going to make changes to the configuration file and set systemd cgroup from false to yes. sorry. Then we will restart containerd service. Next, we will restart the kubelet service as well. And finally, we are going to enable the kubelet service. Good. So we are done for this step. We have successfully installed Docker, and we have made all the required configurations to the containerd configuration file. All right, so now the next step, we are going to initialize the Kubernetes cluster on the master node. In this step, we are going now to initialize the Kubernetes cluster on the master node. Now, when you initialize the Kubernetes cluster, you are going to deploy several components to manage and orchestrate the cluster. So this includes the Kube API server, the Kube controller manager, the Kube scheduler, the etcd, and Kube proxy. Now we need to download the images of these components by running the command sudo kubeadm config images pull. So this command will download the images of all the components required for the Kubernetes control plane. So now hit enter. All right, so this is going to download all the images required. So it's going to pull all the images, as you can see on the terminal. Okay, so just be a bit patient as this goes on. Great, so the images for all the components on the control plane have been downloaded. Okay. Now to initialize the master node, we are going to configure a pod network. All right. And now to do so, I'm going to run the command sudo kubeadm init for initialize. Then I'm going to specify the pod network. So this is the network that is going to be used by the pods to communicate within the cluster. So CIDR pod network CIDR. So I'm going to specify the CIDR. So in this case, I'm going to specify 10.10.0.0 with a subnet of 16. Okay, so here I'm going to press enter to initialize the master. Okay, so you can see the process is ongoing. So this can take a bit of time, so just be patient. Good. So as you can see here, your Kubernetes control plane has been initialized successfully. All right, so down below you can see how to start using your cluster. So we need to run these commands one by one. All right, now at the very end you can see this is the command, the kubeadm command for joining the cluster. Okay, so now first of all, let's run these commands to start using the cluster. So I'm going to copy this and I'm going to run these commands one by one. So I'm going to copy this and run it. and this as well. Okay, so I'm also going to run that command. So now with those commands running, we can now start using the cluster. Okay, so now what we're going to do is we need to now copy this command here, the kubeadm copy command, that is now going to be used, that we are now going to use to join the worker node to the cluster. So I'm going to copy this. So in your case, this will be different depending on your setup. So we're going to copy this command and we are going to save it somewhere safe, okay, for joining the worker node to the master. All right, so now next step, we are going to configure Calico and kubectl. The next step is to install Calico. Now Calico is a container networking solution that allows Kubernetes workloads to communicate seamlessly and securely, and it provides high performance and low latency for effective communication between the pods. All right, so now on the master node, to deploy Calico, I'm going to copy and run this command here. Okay, so I'm going to copy this and run it here to deploy Calico. So as you can see, the resources are being created. Okay, I'm going to clear the screen. Next, I'm going to download the custom resources file for Calico, and this contains the definitions of the various resources that Calico will use. So once again, I'm going back to my notepad and I'm going to copy this command and I'm going to paste it and hit enter. All right, so this has downloaded the custom resources file. So you can confirm this using the ls command. Okay, so here is the custom resources YAML file. All right, now after you download the file, we need to make a few changes or modifications, okay, to match the pod network. All right, so now once again, I'm going to use the sed command to change the default CIDR to the CIDR that my pod network is using. So now here I'm going to copy this command, as you can see. So I'll copy this and paste it here. So this changes the CIDR from 192.168.0.0 with a subnet of 16 to the pod network that my cluster or the cluster is going to run. So this I'm going to have specified 10.10.0.0 with a slash 16 subnet. Okay, so I'll hit enter. All right, now I'm going to use kubectl to create the resources defined in the custom resources YAML file, and to do so, I'm going to run the command kubectl create -f, then custom resources.yaml, then I'm going to hit enter. All right, so as you can see from the output, we can see that the resources have been created. All right, so now in the next step, we are going to add the worker node to the cluster. Okay, now the last step is to join the worker node to the Kubernetes cluster, of which the master node is a part of. Now to do so, you're going to use the kubeadm join command that we saw earlier. All right, so this was generated when you were initializing the Kubernetes cluster. So you remember that command I told you to save. So in our case, we have saved it. So here is the join command that was generated. So in your case, you're going to use that command to join the worker to the Kubernetes cluster. So we are going now to switch over to the worker node. All right, so here we are at our worker node, and we're going to paste that command and run it, okay, to join the worker node to the cluster. So I'm going to hit enter. All right, now you can see the command is running. Okay, so just wait a bit for it to execute. Okay, so on your terminal you're going to see that output. Okay, now here you can see that this node has joined the cluster. Okay, so at the bottom you can see run kubectl get nodes on the control plane, which is the master node, to see this node join the cluster. All right, so now what might be a bit confusing is the IP address that you see here. Now this is the public IP address of the master server. Okay, so this public IP maps to the private IP. So let me just demonstrate here. So now this is the public IP address of my master node. Now this maps to the private IP you see here, which is 10.170.16.31, as we saw earlier when you were setting up the hostname resolution. Okay, so that is why Kubernetes has decided to pick the public IP address instead of the private IP. But if your setup is locally, maybe you are on a local area network, this should correspond to the IP addresses to the private IP that have been assigned by your router. All right, so now we are going to copy this command, kubectl get nodes. Okay, so now we're going to copy this command, and we are going to run this. Now we are back to the master node, so we are going to run this here. So we are going to run the command kubectl get nodes, and you're going to press enter. And there you see, now we have two nodes. We have the Kubernetes master node, whose status is ready. Okay, and this plays the role of a control plane. Okay, now here we have also the worker node, which has joined the cluster, and its status is also ready. Okay, now you can list all the pods from all the namespaces using the kubectl command line tool. So you can run the command kubectl get pods -n, or rather you can get pods -a. Okay, so you can see these are all the pods, okay, in all the namespaces inside the cluster. So here you can see the Calico API server, Calico system, kube system, and so on and so forth. All right, guys, now this brings us to the end of this lecture, and we have demonstrated how to install Kubernetes on Ubuntu 22.04. It's been a pleasure walking you through. I hope you found this helpful and insightful. If you did so, don't forget to leave a like and subscribe to our channel for more informative videos such as these ones. So that's it guys. So see you in the next video lesson.